Coming up next, I'm going to be talking about graphing quadratic inequalities. But in the meantime, do me a favor, like, share, and subscribe to the channel. Another math jewel coming up. What's up, everybody? My name is Dana Harris with Young Gurus Math Tutoring, and I'm back again to drop some more math jewels. In this video, I'm going to be showing you how to graph quadratic inequalities. Now, this lesson is going to be simple and sweet because I already have pre-drawn the graphs of the inequalities. But the main thing I want to talk to you about is shading with these inequalities. So you're going to graph these quadratic inequalities just like you would graph a quadratic equation. So here in this example, I have y is less than negative 2x squared minus 4x minus 4. So as you can see, I have this parabola graphed as if it was just y equals negative 2x squared minus 4x minus 4. But notice, here's the thing. Since it's less than, we know that this actual parabola, any point on that parabola is not part of the solution. So it's a broken parabola. That means, or dashed, however you want to describe that. Now, because our solution is less than, we want to shade below the parabola. So we're actually going to shade inside here. So basically anywhere in this area under that parabola will satisfy that inequality. All right. So once again, less than, that means we have a broken parabola and we're going to shade under the inequality. You would graph this as if you would graph the regular quadratic equation. In this example, I have a different quadratic inequality, but this time we're going to have y is greater than 2x squared minus 8x plus 6. Please see the video on graphing quadratic equations if you're not familiar with how to graph a quadratic equation, because you're going to graph this inequality just like you're graphing the quadratic equation, but the only difference is here we now have greater than, and so we still have the broken parabola, but at the same time, now we're going to shade above it because the solution set is greater than this parabola or this quadratic inequality, right? So we're going to shade anywhere above it. That means anywhere inside this area above it and continuing infinitely is part of your solution set. Notice the broken line means no points on that, or the broken parabola means no points on that parabola are part of the solution. In the next example, notice our inequality symbol is less than or equal to. So we graph the parabola just as if we were graphing y equals 3x squared minus 6x minus 1. But this time, the solution set is less than or equal to. So that means your solution also is on the parabola. So any point on the parabola is also part of the solution, but it's less than or equal to. So everything outside here is shaded. All this area outside here is shaded. All right, let's go here. All this is part of your solution set. All right, and one of my recommendations is actually whenever you are graphing inequalities, in order to show your solution set, I suggest using a different color. Like we can actually go in different directions and make this all like a piece of art, make it a little steam. But notice once again, the difference when you have less than or equal to, we're shading below the parabola, but also all of these points on that blue parabola represent part of the solution set. And in this example, our last and final example, we have another example where we have the greater than or equal to now. So y is greater than or equal to negative x squared minus 4x plus 4. In this case, notice the parabola is solid now because we have the equal to portion on the inequality. So it's greater than or equal to, so we're going to shade above the parabola. So everything out here, anything in this area is part of the solution set, okay? And what do we mean by the solution set? What we're basically saying is if we take any ordered pair either on this parabola or out here in this pink space, the shaded space, if we put the x and y coordinate and substitute it into that inequality, we're going to get a true statement. That's the important part of it. And anytime if you are in question as to whether or not you shaded properly, I always choose a point in the, I'll choose a arbitrary point. So for example, and when you choose an arbitrary point, use simple points like 1, 1, 0, 0. I typically, my rule of thumb is 0, 0. So if I use 0, 0, then if I substitute 0 for x and 0 for y, I should get a true statement. In this case, if 0 is for y and 0 is for x, 0 is greater than or equal to 4 is a false statement. So that tells me that this is not part of my solution. But at the same time, if I choose something like, let's say 5, 0. If I choose 0, 5, right? 5 is y, and I choose 0 for x. 5 is greater than or equal to 4, so that lets me know that is part of the solution set. Please take the time to look at the video on graphing quadratic equations, and that will help you determine how we graph the parabola. And then the simple part of graphing the inequalities is the proper shading and making sure you have the parabola that's either solid or broken. Thank you so much for watching this video. Remember to like, share, and subscribe to the channel. Young Gurus Math Tutoring. I've got the solution to your math problems.